Now here, once we have done this create master array, yeah, then you get a master array of unique characters. So let me show you the create master. This you have already implemented. I'm just giving you an overview of what you've already done. Create master array. Here we are. Create master array. In the create master array, here we begin. We find the size of file, and then we see, and then we allocate space for 128 characters, and then we get the master array like this. While read a character from the master file, input file one by one, and if needed, if it is unique, then put it in the master array. How unique? Well, you call a unique function. Look at the way you have made the function call and capture the values back from the unique function. This is the standard of coding that is required. Hold on. This is it. Okay. So unique function takes data sets of a unique as argument, and it checks whether the character in question, that is this, is found in the master array or not. You go through the whole master array and check, you find your character in the master array. If not found, then you return through the flag that okay, not found means flag 0 means not found, 1 is found. And return value is now used by the if condition here, and when the return value is used by the if condition here, you are able to find it. Okay, fine, it's unique or not. If it is unique, you store it in the master array. If it is not unique, you skip it. And the file size keeps on decrementing. You go through the whole input file, and finally you have the master array ready, and you return the master array back. The return to master array comes here in this master array. Then depending on the size of master array, you find the code length. We implemented the code length function also earlier. Code length. The code length function is here. You return the code length, whatever code length you had. 2, 3, 4, 5, 6, 7 are the options. And depending on 2, 3, 4, 5, 6, 7, whatever code length, you call the appropriate compression function. Compress 4 we have implemented. Compress 4 we have implemented. This is compress 4 function, in which we have fully implemented the compression algorithm, and the compression was successful. I remember, isn't it? And then compression is done, and then we return back. This is your compression function. We return back, and then this is your main menu function. We return back. Okay, and then this is your main function. So look at this once again. Look at this. This is the standards in C that is required. Any ordinary person who will see the statements like this will get properly confused about what is happening here. But this is actually needed here in device drivers or kernel development, where you should be able to pass a function as an argument to another function. Function A should pass function B as argument, and the function B will have their own arguments, maybe 8-char float, something like that. So this kind of programming skills you should have right now. This is the aim of this project in C, that number 1, you should be able to work with generic functions, area function pointers, and number 2, you should be masters in bit manipulation through bitwise operators. Okay, so now we return back to main function. Here we are, and we'll go to decompression today. So in the main function, I will call main menu, and the main menu function will today give choice number 2, decompression, and from here we'll call the decompression function, and we will begin decompression today. Decompression. Oh, we don't have it or what? There it is. decompression begin. Okay. What we'll do in decompression is very much similar to what we did in compression. Remember compression function? Let me open it for you. See this, the compression function. We'll take some cues from this compression function. So very first thing we did in the compression function was give the name of file to compress. Okay. Now in the decompression, we'll say give the name of file to decompress. Now we are going to do reverse of what we did in compression earlier. So in the compression, okay, fine, give the name of file to compress. Okay. So we'll give the name of file to decompress here. Initially, I'll write some code for you. So it says give the name of file to decompress. See, you have already compressed the file. Fine. Now you know what is the name of the file that you have compressed. Original file you had, you compressed it. Now you have a compressed file. So you'll give the compressed file name here, which you want to decompress. Okay. How do you do that? Okay, fine. First you have to open the file. Okay, get char will be needed here also. So we will put it here. The effort that we put in the compression function earlier will be so fruitful here. So this is the call to the open file function. You're going to open the open file function. The open file function will be called from here. And there it is. Look at this. I would like to ask some questions here. Abhinandan, can you tell me what is FPTR here? Come on, fast, fast. Array of function pointers. And what does this 6 signify here? There it is. Very good. Very good. And what is this reading? Why we have typecasted this argument to void? Very nice. And why did we typecast the return value to int pointer? Very good. Look at this. Pointer. DC. What is DC here, by the way? Okay, look at this. Decompression. What is the argument passed to decompression? Look at this. Argument passed to all functions is 0. Null. Okay, we don't have any argument. We're not passing any argument to the decompression function. So when this open file function will open the file descriptor, that file descriptor will be stored where? Data structure for compress. So this is the data structure for ds compress is the name of data structure. So ds compress has to be declared. ds compress data structure for compress. We declare this structure variable ds compress. Okay, this data structure, this data structure for compress will have an integer pointer. Watch this. Line number 13. It has the integer pointer here, isn't it? This integer pointer that you find here has to be initialized with the file descriptor that is coming from this. This you have made a call to the open file function that you have written, and this call is made using generic functions that are through the array of function pointers. The syntax that you see in line number 13 is what is required when you go for embedded programming, kernel programming, device driver programming, network protocol stack design. So there you have to use these generic functions, and this kind of coding will be required. These are the C standards which are expected from you if you plan to get into some product development firm. So I have spent a lot of time explaining you how to write this kind of C program. Okay, I feel you are comfortable in that. If not, then ping me, connect with us. We'll arrange a separate jam sessions for you where we'll be able to help you there. Okay. Now we've got the file descriptor. What did we do in the compression function earlier? Oh, we printed it. Let's print it here also. This will be a checkpoint for us. So here we will print it. Here we will print it. We'll call it not IFD, we'll call it compressed CFD, compressed file descriptor. and this will be printed through DC points to FD. So if we are able to print this file descriptor correctly, that means we are able to open the compressed file, which we will be decompressing now. This is the checkpoint for us. We wait, we do it now. See how we are going to run it. Let us save all the files. Save and save and save all the files. Now save all the files, and here we have written a make file for it. Have we? Yeah, there is a make file for it. This is the make file that we have written. Yeah. Okay. No new file is added. So we have written a test script also for it. The test script is here for it. So here we have check-in. Okay, we are using RCS. Check-in, check-out we are doing. So we are using a revision control system for it. So very first thing we have to do is we should close all the files, because RCS will check in all your files into the RCS file where the documentation would be done, and the revision control system will keep all the revisions that you've done to your code. Yes, Harsh? Can you repeat that? The audio was not clear. Please repeat that. We missed it. Sorry. This file has to be included. Nice. There it is. Let's build it now. Okay. The test script. Okay. Do you want to check in? Oh yes, definitely. You want to check in all the files. Decompression.c. What did we do? Opening the already compressed file. Okay. And obtaining the file descriptor, and finally printing it for testing purposes. We are testing whether we are able to open the compressed file or not. That's all. No other changes we have done. Do you want to check out for build? Oh, definitely yes. Do you want to build your project? Yes, we do want to build it, and we are building the project. Everything is built properly. Project built successfully. Do you want to run? Yes. One for compression. There it is. We did compression. Give the name of the file to compress. What is the test file we have here? What is the test file? A text file is the file that you want to compress. Okay. Text file in which we have some test data. Okay, enter compressed file name. We want a file called COMP file, which will be our compressed file. Give encryption key. We will have to give an encryption key that will be required for decompression. Let's call it ENCKEY, encryption key. Done. Compression is done. Let's check. Long listing. The name of the input file was text file and the size was 38 characters. We have created a comp file, compressed file. Comp file, oh, size is 19 characters. And we have created an encryption key also. Oh, there is the encryption key. Nice. Now we will start working on this compressed file. This is not only compression, this is compression and encryption as well. See when I open this file. Encrypted, isn't it? Later on, multiple iterations, we will take this compressed file as input and see if we can compress it further. We'll compress it further. Okay. Anyway, So again, we go back to the menu. Choice number 2, decompression. 2, enter. Give the name of the file to decompress. COMPFILE. Enter. Oh, we got the compressed file descriptor number 3. Congratulations. We are able to open the decompression, the compressed file that we are going to decompress. So this completes the test for us. We are going to exit the program now. Do you want to check RCS, revision control system is asking us. Do you want to check out your further development? Suppose you want to do further development today, you give yes. Otherwise, you can give no, you do it tomorrow. But you want more to be done now. So I give yes. All the files are locked, and the revision that we did in the program was finalized, and we can proceed further in further development. Go ahead. So we are going to open the decompression file once again. So while compression, if you remember, we created 2 files. One was the compressed file, one was the encryption key. So we'll have to open the encryption key file also. Same thing again, give the name of file to compress, give the name of encryption key. 1, 2, 3, 4, 5, 6. I want to copy these 6 lines, 6YY, and put it here. This time I'm going to open, give the encryption key. Encryption key. Give the encryption key. That also in the reading mode, and the file descriptor number will be say E key, EKY, E key. So E key is the encryption key that we are going to use, and E key. Okay, this E key will be used to open the encryption key file in which we have stored the encryption key, and we will display E key file descriptor also to ensure that okay, we have opened it successfully. This will be our test checkpoint again. So stop and test your program once again. Begin. Test script. Check in. Yes. Decompression. Open. Obtaining the encryption key. That's all. Do you want to check out for build? Of course, yes. Do you want to build your project? Yes. There is some warning. Compression.c line number 22. Assignment from int to int from install. Do you want to run the project? No, not with warnings. No. Do you want to check out for further development? Yes. Let's fix that. Now look at this function that I called in line number 22. Open file. Let's see that function. This function is returning void pointer, and we are capturing this void pointer in and out. We are returning void pointer. Okay, this open file function is returning void pointer. Fine. The returned void pointer is being typecasted into integer pointer, and integer pointer is being stored in integer. This is not right. So what we should do is this function will return void pointer, typecast that void pointer into integer pointer, and then from that integer pointer fetch the integer, and that integer will store in EP. You are able to understand this? Yes, no? I see thumbs ups. Nice. Ask me any questions if you have now. Let's test again. Do you want to check in? Yes. Some typo. Do you want to check out for build? Yes. Do you want to build your project? Yes. Do you want to run project? Yes. One for compression. We have already done that. No? So we'll straight away go for decompression now. 2. Give the name of file to decompress. Com file. Enter. We got compressed file descriptor number 3. So that's already working properly. Now give the encryption key. ENCKEY. It says no such. Oh, did we give wrong file name? What is the name of the file? No. ENCKEY. What did I give? Oh, I gave a wrong file name. Do you want to check out for further development? No. I want to run it again. Do you want to check in? No. Do you want to check out for build? No. Do you want to build project? No. Do you want to run project? Yes. I want to decompress to give the name of file to decompress. Comp file. Give the encryption key ENCKEY. ENCKEY, it's correct now. Oh, it is not taking E. It is taking NCKEY. It is skipping E. Do you want to check out further development? Yes. Let's go back to decompression function and remove this extra get char that you have here. We'll comment it for now. I'll explain it to you once I'm able to implement it properly. Test again. Do you want to check in? Yes. Do you want to check out for build? Yes. Do you want to build? Yes. Do you want to run? Yes. 2 for decompression. Give the name of file to decompress. COMP FILE. It's given correct. Okay. Give the encryption key ENCKEY. Okay, there it is. Oh, E key number 4. Congratulations. We are able to open the compressed file and we are able to open the encryption key as well. Over. Do you want to check out further development? Yes. Now look at this. You are able to open it. You are able to return void pointer, typecast it to integer pointer, and fetch the integer out of it. So look at the syntax. This is the standards in C that you need. All the people who have implemented compression and 4-bit compression you have done, compressed file is created. I would request you to please go ahead, open the compressed file. You would have created the encryption key also. Open the encryption key. Demonstrate the file descriptors, and then next working day, we will start decompression. Guys, you have worked very hard in C with me. You have reached these standards. Now it's time to give it finishing touch. Complete the project the day you go for interview. Take it with you in the pen drive. When you talk about this, people will ask you, not only ask you, they will dig deeper into how you use generic functions. And what is the basis for compression. The various interview questions come. I'll give you the set of interview questions also for that. And sometimes if the interviewer have time, they will like to see your code. Not only code, the beauty of this is, look at this, the logs. Let me create the log script, run the log script for you first. The log has been created with today's date. What is the date today? 13th September 24. This is the log for today. This is the log for today. What we have done in this project. The whole story is here. Anybody can read this and see how you did this development. Right from the beginning of compression till the end of compress 4, and then now beginning decompression. We have worked on a particular file called decompress, right? And let's check decompression. There it is. The decompression file. What did we do today? Here it is. Well, we created 6 versions. Okay, here it is. In the first version, second one, oh, here it is. Opening the already compressed file, obtain the file descriptor, printing it, obtaining the encryption key. Then I didn't give any further messages. This function is going to decompress and just checking mapping for now. So like this, you have done log for every function that you see here. And then you'll have this code with you. You'll have this logs for everything that you've done in this project, right from the beginning till end. Well, this is called coding standards. And this is how every manager would like you to keep your code and have the logs created simultaneously. Okay. So if you have any questions, you can ask me now before I close today's session. I'll do the decompression part in the next session. Any queries from anyone? Mhm. So your question is that other than the 4-bit compression, are we going to discuss 2-bit, 3-bit, 4-bit, 5-bit, 6-bit, and 7-bit compression also? है ना? Well, 4-bit compression and decompression I will assist you to do. I will also do 3-bit compression with you. When I'll finish 3-bit compression also with you, you will understand how to do the rest of the compressions. From then onwards, I'll not give you sessions. I will just take query sessions where you can ask your queries to. Anybody else have any question? I have somebody asking some question. Mr. Hamster asking like why cast void pointer to string literal? Well, if you can hear me, I'm telling you, we are using generic functions. All the functions are using void pointer, and all the functions are taking void pointer as argument. You know, so the void pointers when go into the function in the called function has to be typecasted into appropriate data structure. At the same time, the called function is returning void pointers, which has to be again converted back into the data type that is required. Yeah, that's absolutely right. The function pointers are not required for simple coding or for software development. The function pointers, rather array of function pointers, will be required when you'll be writing your network protocols or device drivers. For example, suppose you have a USB hub, and in this USB hub you connect a USB, and on the hub if you have a 4-port hub, you connect a internet dongle, you connect a mouse dongle, you connect a keyboard dongle, and you connect a camera, USB camera. You have 4 different kind of devices. So all 4 devices goes into a single function called USB. So you have to learn to have 4 different type of devices connected to one port. So the function of camera, the function of connected devices has to go into function of USB. So we have to learn how to pass a function as an argument to another function with the XYZ arguments. And all the devices that are connected to USB hub has to be put into array of function pointers. So that's the architecture of device drivers. That's why I'm right now training everybody to be ready for that kind of coding. Yes, that's right. The function cannot be inline. The function should not be inline. The function, if put inline, will make the size of code very big. And if the size of code is big, then you'll need more flash into your device. If your device is some kind of high-end embedded device like routers, you can have more flash. But simple devices like camera, keyboard, USB mouse, keyboards, and simple dongles cannot have enough flash. So you have serious restrictions there. So we cannot have inline functions. Anybody have any more queries? Very nice. I enjoyed the session with you guys. I'll schedule the next session hopefully on Wednesday, and same time you can connect, and by that time you should be able to open both the compression file and the encryption key, and then we'll start 4-bit decompression. Okay. So wish you good luck. If you have any query, you can use the discussion forum to connect with me anytime. So bye bye. Good night. Take care. By the way.